Okay, now we shall continue with our steady state error. So just see some problems and try to understand how do we use those equations what we have learned so far. Now in this problem we are asked to find the values of Kc and Kd, which are the constants of this system block diagram, provided the error coefficient, which is the velocity error coefficient, is 10,000. So sorry, this is 1000 and zeta value is given as 0.5. For these two values we are asked to find what is Kc and Kd. So now from this let us try to find out what is GFS. So GFS is nothing but just a product of this into this, 100 into Kc plus Kds divided by S into S plus 10. So we know that Kv is nothing but limit of S tending to 0 S into GFS. So let me use that term GFS what is there given for this one. So it is limit of S tending to 0 S into GFS is 100 into Kc plus Kd into S divided by S into S plus 10. This S will go with this. When I apply that limit of S tending to 0, this will also become 0, this will also become 0, and of course we know that this is 1000. This is what is 1000 given. So now can I write, so this is 1000 is equal to 100 Kc by, because this is 10, this will go with this. So now can I find what is Kc is equal to 1000 by 10, this will become actually 100. So Kc is now 100 from this. Now we are asked to find what is Kd. Of course it's very simple. So since Kv is given, we are actually substituting what is Kv is. So before that, because we know that Kv is nothing but S into GFS, I need to find the GFS of this, which is a unity feedback system. I want to find the forward block, which is the product of these two, because these two are in series. That's what I have here. And then Kv is nothing but S into GFS. So you're substituting what is GFS. Before you apply the limit, make sure that wherever S will going to cancel out, then you apply the limit. So now this becomes 100 Kc by 10. So then that reduces to Kc as equal to 100. And we are also asked to find the value of Kd. The value of zeta is given. So zeta, we know that it is for a second order, because there is a damping ratio. So let us try to find what is CFS by RFS of this. CFS by RFS of this one, which will be, so I can write it as, it is 100 into Kc plus Kds divided by S square plus 10S plus, it is 100 Kc plus Kd. Yes, so this is my equation. So once I know this, I can equate this to the standard form of second order equation, which is nothing but S square plus 2 zeta omega n S plus omega n square equal to 0. So I can actually put this in standard form of, I can just group it, so that now this becomes S square plus 10 plus Kd this is there, and then I write it as 100 Kc is equal to 0. So this is my standard form. I'm trying to bring this into with the quotients of S square as 1, with the quotient of S as 10 plus Kd, and the quotient of s power 0 as 100 kc. So since we know already the value of this s, so this is now s square plus 10 plus kd into s plus 100 into 100 is equal to 0, because kc was found out to be 100. So then equating this and this, equating this standard form and the form that is there given for this block diagram, so from which we can write, so can we write omega n as 100? So now omega n is 100 now from this, equating this and this, because this is omega n into omega n, this omega n square, this omega n is 100 radian per second. So 2 zeta omega n, that's what is 2 zeta omega n is, okay, we know what is zeta. Zeta is given as 0.5, omega n is 100. So is it not 2 into 0.5 into 100? This again happens to be 100. Is this 100 is equal to 10 plus kd? So now I can write quotient of s is 2 zeta omega n, which is the standard one, and for the equation it is 10 plus kd, 10 plus kd. So that's what we have here. This is the quotient of this is not 10 plus kd, this is, no, this is actually 100. I need to multiply this by 100. Okay, let me just make it by 100, because that 100 need to be multiplied to this. So now this is 10 plus 100 kd. So let me just make this is again 100, is 10 plus 100 kd is equal to 100. So then what is kd? Okay, 100 kd is equal to, because this 2 zeta omega n is 100, so is it not 100 minus 10? Then what is kd? Is it not 90 by 100? So is it not 0.9? So kd is equal to 0.9 and kc is equal to 100. Kc is equal to 100 for this problem. For this is straightforward. Only thing is that the error coefficient thing is got from this, has been obtained from this. Let us take one more problem. So let me take so let us consider a block diagram which is something like this here. This is KA and I have this as 1 over s into 0.1 s plus 1, and there is a negative feedback to this, this is R of s, this is C of s. Now we are asked to find what is ESS for a input of 5 ut plus t. So it is a combination of input which is having a unit step of magnitude 5 and a ramp input. So now okay, let us try to focus. So this is the second part of the problem. The first part is actually we are asked to find the value of Ka so that the system reaches steady state in minimum time with no overshoot. This is minimum time, no overshoot. So we are first supposed to find the value of Ka that system takes to reach the steady state in minimum time with no overshoot. So this actually gives a clue for zeta to be 1. Zeta to be 1. So taking zeta as 1, first we need to find the value of Ka. After finding the value of Ka, we need to find what is the error. This is the first part, this is the second part. So looking at this transfer function, so GFS as equal to Ka by S into 0.1 S plus 1. And what is its CFS by RFS? CFS by RFS is equal to so what is this now? 1 over S into 0.1 S plus 1 plus of Ka. Plus of Ka is my CFS by RFS. So what is this now comes out to be? Is it not equal to 1 over 0.1 S square plus S plus Ka? This is what is the equation. So if I want to bring it to the standard form of S square plus 2 zeta omega ns plus omega n square, I have to make the quotient of this S square as 1. So to do that, I have to take out 0.1 outside. So CFS by RFS will become, if I take 0.1 outside, so it is S square plus 10S plus 10 into Ka. So now, so what is this equation? So this equation now becomes CFS by RFS is equal to 10 by S square plus 10S plus 10 Ka. So the denominator of this transfer function is equated to the standard form of S square plus 2 zeta omega ns plus omega n square. So from which I know the coefficient of S power 1 as 2 zeta omega n, that is equal to here it as 10. So now I know the value of zeta. What is the value of omega n? So actually from this omega n is, because omega n square is 10 into Ka. So what is omega n? Then it is a root of 10 into Ka. So I can make this equal to zeta is equal to 1, because in the problem it was said that it reaches the steady state in minimum time with no overshoot. So that gives a clue of zeta. So it is 2 into 1 into root of 10 Ka is equal to 10. So I need to find out what is Ka is. So I can find the value of Ka now. I need to simplify, I can just feed it as it is. So it is 2 into under root of 10 into alpha a, close the parenthesis, alpha equals 10 shift cal. That will give me the value of Ka as 2.5. Ka is now 2.5. So you can directly give it, or you can just simplify this and get it. Otherwise your calcs will do it. The way how I did is 2 into, of course 1 is relevant, into under root of 10 into K is to be found, it is alpha a, close the parenthesis, and then alpha equals, it's equal to 10, then shift cal, it is 2.5. So once you know the value of Ka as 2.5, now you can find what is the error. So what is GFS now? So earlier we were not knowing what is this Ka is. So now what is GFS? GFS is equal to Ka by S into 0.1 S plus 1. One second. This is 2.5. Now we need to find what is ESS. Sorry for now ESS for R of t, which is 5 unit, okay, 5 times unit step input plus ramp. It is now nothing but 5 for unit step. It is 1 plus kp. For ramp it is 1 over kV. Now we need to find the value of kp and kV to find what is overall ESS. So what is kp now? Kp is now limit of s tending to 0 GFS. So this is my GFS, which is nothing but limit of s tending to 0 2.5 by s into 0.1 s plus 1. When you apply the limit of s to 0, so this will become 2.5 by 0, this will become infinite. So kp is infinite. So let us find what is kV is. For kV, to find kV, we know that it is limit of s tending to 0 s into GFS. This is now again limit of s tending to 0 s into 2.5 divided by s into 0.1 s plus 1. So I am just writing what is GFS. This s will go with this. When you apply the limit of s tend to 0, this will become 2.5. So because this is 0 now, again now it is 2.5 by 1. So kV is 2.5. So now this is 5 by 1 plus infinity plus 1 over 2.5. So this is now 0 plus 0.4. This is what is ESS. So ultimately the ESS for this system is 0.4. When you have an input which is a 5 step input, 5 units of step, and a ramp input, the ESS is 0.4. So let us find it for one more problem. This is my system having a block which is 0.5 s plus 1 divided by s into s plus 1, and I have one more block which is 1 over s into s plus 0.5, and I have a unity feedback system. Since the system is unity feedback, I can apply ESS as in terms of Kp, Kv, Ks. This is RFS, this is CFS, this is negative feedback. We are asked to find what is ESS. ESS given the input as 10t plus 0.1 t square. This is my input. This is the input. So we know that ESS, when a ramp signal is given, it is 1 over kV. Since it is 10 times, I'll make it into 10. It's like 10 by kV. Let us bring this to a standard form of t square by 2. I will multiply and divide by 2. So this will become t square by 2. For t square by 2, it is 1 over Ka, the ESS. But since it is t square by 2, afterwards this will become 0.2. So multiplied by 0.2. So ESS, you should find it as 10 by kV plus 0.2 by Ka. Let me tell you again why we are just doing this. So can I write it as 10 into t plus 0.2 into t square by 2? Because for this t I have a error of 1 over kV. For this t square by 2 I have an error of 1 over ESS of 1 over kV. Since it is 10 times, I am making it as 10. 10 by, of course this is simply multiplied by 10. How much is this? This is simply multiplied by 0.2. So that's what is 10 by kV and 0.2 by kV. Now the question is, we need to find what is KVKS. What is, before that we need to find what is GFS. GFS is the forward transfer function. What is GFS here? GFS is now equal to, so I can write GFS. So, okay, let me write GFS is nothing but product of these two, which is 0.5 S plus. Okay, now you may just even cancel this out, there's no issue. So it is S plus 1. So you may just wonder that, okay, oh, S plus 1 both are there, why not cancel it? Now we can cancel it, doesn't matter. So it is S into S plus 1. You have a pole and a 0 at the same point, and it is S into S plus 0.5. So this will go. So can I write it as 0.5 S square by S plus 0.5? So this will become a type 2 system. This is GFS. So what is KV now? KV is limit of S tending to 0 S into GFS. So it is now limit of S tending to 0 S into GFS is 0.5 S square into S plus 0.5. This will go with this square. This S still remains. When S is tending to 0, anything by 0 will become infinite. So this is KV. Now you apply the limit of S tends. So this S and will go with this square. S still remains with the denominator. When you apply that limit, it is like 0.5 by 0 into 0.1. So that will become infinite. What is KA now? It is limit of S tending to 0 S square into GFS. So it is S square into 0.5 S square by S into 0.5. So this S square will go with this. When you apply that limit of S tending to 0, this will also go to 0. So this is now 0.5 by 0.5. Then KA is 1. KA is 1. Now we substitute this as, what is ESS now finally? ESS is 10 by infinity, and it is 0.2 by 1. So this is 0 plus 0.2. So this is my F. So ESS now is equal to, for this particular problem, so ESS is 0.2 for 10t and 0.1 t square, 0.1 t square. So this is F. Is it fine? This is how you can able to do the problems. Of course, you can try out many such problems. Only thing is that whenever there is a unity feedback, you can use the error coefficient KA, KP, KVs depending on the type of input you have. So we will have different KP, KV, KS. Thank you.